Hello friends, welcome to Align Pattern. As promised from the previous session, let's discuss about deadlock in operating system in more theoretical way. This is one of the most important topics in operating system, and if you are preparing for the interview or for any exam perspective, so this video will be very helpful for you. So without further ado, let's get started. So we can start from the proper definition of deadlock. Okay, actually deadlock is the situation or condition in which two computer programs sharing the same resources are effectively preventing each other from accessing the resource. Okay, let's take a simple example. Suppose we have a two process P1 and P2 and two resources R1 and R2. Okay, now let's consider P1 process accessing the R1 resources, and R1 resources is already allocated to P1, but the thing is P1 is requesting to R2 resources here. Okay, but again R2 resource is already allocated to P2 resource, and at the same time P2 is requesting for the R1 resource. Okay, in simple manner we can say P1 is holding the R1 and P2 is holding the R2. Until P2 releases the R2, P1 cannot access it, and until P1 releases the R1, P2 cannot access it. Right? So this whole situation we can call it as a deadlock. That's why our definition says that a deadlock is nothing but the situation where two or more processes are unable to continue executing because they are waiting for each other to release the resources. Got it? It's very simple. Consider the real life example of deadlock. Suppose we have two cars crossing each other and they are stuck while moving at a narrow bridge. Okay, and each driver of a car insists on going first. So in this situation, car cannot move and traffic is get blocked in both the direction, right? So here the whole situation is considered a deadlock. Another example is like two people are holding onto a door handle from the opposite side and neither is willing to let go. In this situation, door cannot be opened nor closed and both people are stuck. This condition or the situation is called as a deadlock. So I hope you can understand the exact definition and meaning of deadlock. Right, now let's consider what are the conditions for the deadlock. Actually there are four conditions for deadlock. Mutual exclusion, hold and wait, no preemption, and circular wait. Deadlock may occur when processes are in mutual exclusion, or when the process is on hold and wait state, or in no preemption, or process is in circular wait. When all the four conditions must happen simultaneously, deadlock may be occur, or in simple manner we can say these four conditions may lead to a deadlock. Right? Mutual exclusion means there is no sharing of resources. Resources are non-shareable. Okay, only one process can use a resource at any given time. For example, printer is the best example of resources that can be used only one process at a time. That is the mutual exclusion. Then the next is hold and wait, means that the process can holding only one resources and waiting for another one. This is one of the possible condition for deadlock. For example, suppose process P1 is requesting for R2 and holding for R1, P2 holding R2 and requesting for R1, right? Then the next is no preemption. No preemption means a resource can be released voluntarily by the process itself. Only the process can itself release the resources. Means that the voluntarily release the resources. Now we are going for the circular wait. So what is the circular wait? Circular wait is nothing but the set of processes waiting for each other in a circular manner. That is the circular wait. For example, suppose we have four processes line up as P0, P1, P2 and P3. Okay, P0 depends on P1, P1 depends on P2, and same way P2 depends on P3 and again P3 depends on P0. This creates a circular relation between all these processes and they have to wait forever to be executed. This circular fashion we can call it as a circular wait, which is one of the main reason of deadlock to occurs, right? All four conditions are necessary for deadlock to occur. If any single one is prevented or resolved, the deadlock is resolved. Got it? Then the next is how we can handle the deadlock if it is occurs in the operating system. Deadlock could be handled by the four ways. First one is very simple term, that is ignoring the deadlock. In this approach, operating system assumes that deadlock never occur and it simply ignores the deadlock. This is being used by many operating systems, mainly for the end user uses. This approach is the best suitable for a single end user system where user uses the system only for browsing and all other normal stuff. For example, suppose printer want to access the multiple process such as we can say the process P1 and P2. Printer wants to access process P1 and P2 simultaneously. Then surely deadlock will be occur, right? So, whenever deadlock occur in this situation, ultimately your PC or laptop will hang, or we can say operating system at that time would not be function properly, right? That time you just want to restart your computer, and when you restart it, so that the problem will be rectified. So this whole situation is nothing but the deadlock ignorance. We just ignore the deadlock here by restarting the computer. Got it? Then the second approach is deadlock prevention. Deadlock prevention, in simple term, we can say that the deadlock prevention is just try to find the solution before the deadlock occurs. Okay, we know deadlock happens for the or the necessary condition for deadlock is only when the mutual exclusion, hold and wait, no preemption, and circular wait hold simultaneously. As we learned earlier, these are the four main conditions for deadlock. If it is possible to violate one of the four conditions at any time, then the deadlock can never occur in the system. Just try to make these conditions false, or just try one of the condition false, that is leads to the deadlock prevention. Got it? Then the next is deadlock avoidance, where the operating system checks where the system is in safe state or in unsafe state at every step, right? So when your system is in a safe state or in unsafe state, in simple terms, safe state means you have no deadlock, and unsafe means you have possibility to have a deadlock to be occur. Okay, as deadlock occur rarely, not frequently. For example, suppose you are calling to your friend, and at the same time he or she might also wants to call you. So this condition happens rarely, right? In the same way, system also leads the deadlock at rarely happens, not frequently. This is just the example to explain in more sophisticated way. Okay, this avoidance ensures that the whenever the system we are using, it never ever enter into the unsafe state. Got it? Actually, this deadlock avoidance method can be explained by using the Banker's algorithm. Banker's algorithm is a very important part of deadlock avoidance. So we will definitely make a separate video for this. It is not possible to explain everything in one single video. It might get very long. That's why we will see in next video. So back in Pavilion, in simple words, the operating system reviews each allocation so that the allocation does not causes the deadlock in the system, right? Then the last one is deadlock detection and recovery. This approach let the process fall in deadlock and then periodically check whether the deadlock occurs in the system or not. Means we are trying to detect, right? If it occurs, then it applies some of the recovery methods to the system to get rid of deadlock, like by making the resource allocation graph or any other method. We are here just trying to detect the deadlock. Makes sense? And when we detect it, we just trying to recover our system. Got it? This is nothing but the simple term of deadlock detection and recovery. These are the different methods to handling the deadlock, that is deadlock ignorance, prevention, avoidance, and deadlock detection and recovery. I hope you understand the concept very well. In next video, we will definitely see what is Banker's algorithm. Till then, watch and learn from the align pattern.